Hello students, welcome to Akash Live. I'm your mathematics faculty and today we're going to discuss the quick solutions of AIATS for JEE Main 2019, test number 3 code E and F for 12th pass students. The test date was 16th of December 2018 and we are going to cover the mathematics portion. So let us start with question number 61. A very simple question based on limits. It says that the value of limit x tends to 0 e raised to power minus sine 8x upon x. So we know that while dealing with questions of this type, we need sine 0 divided by same 0. So if it is sine 8x in the numerator, I need to multiply 8 and divide by 8 so as to get the standard trigonometric limit. The answer will directly come out to be equal to e raised to the power minus 8, which means that option number 2 is correct. A very easy question to start. Let us move on to 62. Question number 62 says that the value of limit x tends to 0, integral 0 to x square cosecant x power 4 up into sine t into cos 2t dt. Integration is with respect to t, so cosecant x power 4 can be taken out of the integration. Limits are in the form of x, which means that the question gives you a direct hint for Newton-Leibniz theorem. Okay, so let us take cosecant x power 4 outside. This can be written as limit x tends to 0, integral 0 to x square sine t into cos 2t dt divided by sine x raised to the power 4. So I think everyone is comfortable with this step. Now, applying Newton-Leibniz formula, differentiating numerator independently, denominator independently, I'll have limit x tend to 0. Differentiation is the differentiation of the limit, that is 2x, into the function value of the limit, that is sine x square into cos 2x square, divided by differentiation of sine x power 4, cos x power 4 into 4x cube. So students, carefully managing the terms. This will be cancelled on the factor of 2x square. This x square will be managed with sine x square, that will be 1. Cos 2x square and cos x power 4 don't give any problem because cos 0 is 1. So the final answer will come out to be equal to 1 by 2. Okay. Option number 2 satisfies. Again, a very simple question once you identify that it is based on Newton-Leibniz theorem. Okay. Let us move on to 63. Question number 63 based on differentiability says that let fx is equal to, three definitions are given, x square plus 1 when x is negative, 1 minus x when x belongs to 0 close to 1 open, x square minus 1 when x is greater than equal to 1. Then the number of points of non-differentiability of the function f of fx, that is the composition function of f, is. Okay. So let us draw the graph for this particular function first of all, and then let us write the definition of f of fx. X-axis, y-axis, x square plus 1 when x is negative, so something like this. This point is 0, 1, so 0, this is 1. Then the definition is 1 minus x, a line with negative slope. This is the line. Green curve is open at 0, this line is open at 1, and the last curve, let us put it in blue color, will be something like this, x square minus 1. Okay, this is x square minus 1, this is x square plus 1, and the line is 1 minus x. Let us mention all the points. This point is 1. Now when we are going to write down the definition of f of fx, students, everywhere in the place of x, I will get fx, so I'll get f square x plus 1 when fx is negative, and this is not the case. By graph you can see that fx is never negative. Okay, then 1 minus f of x when fx belongs to 0 to 1, 0 closed, 1 open. So we have two intervals when fx belongs to 0 to 1. One interval will be the orange line and the second interval will be the blue curve. This point will be root 2. Now again talking about the third possible definition, f square x minus 1 when fx belongs to 1 to infinity. So students, for this particular thing we have three definitions. Green curve is already there, blue curve is already there, and this point x equal to 0 is also there. Okay, so first definition is ruled out, second definition will have two possible options, third definition will have three possible options. So let us write them down. F of fx, the first possibility is 1 minus 1 minus x. So you have two conditions. First condition is that 1 minus x should belong to this interval 0 to 1. Intersection. When fx is equal to 1 minus x, when x belongs to 0 to 1. So again, x belongs to 0 to 1. First possible definition. Second possible definition, 1 minus x square minus 1. So over here, x square minus 1 should belong to 0 to 1. Intersection, fx is equal to x square minus 1 when x is greater than or equal to 1. So this is x belongs to 1 to infinity. Okay, this definition is over. Now let us split this definition into three further definitions. So first definition will be x square plus 1 whole square minus 1. X square plus 1 should belong to 1 to infinity, and fx is equal to x square plus 1 when x is negative. So x belongs to minus infinity to 0. Then second possible definition, 1 minus x whole square minus 1. So over here 1 minus x will belong from 1 to infinity. Intersection, x will belong from 0 to 1. Last possible definition, x square minus 1 whole square minus 1. So this will be x square minus 1 belonging to 1 to infinity. Intersection, x belonging to 1 to infinity. So this will be the last step for the definition. After that we need to find out the number of points of non-differentiability. First will be x simply. Second will be 2 minus x square. Third will be x power 4 plus 2x square. This will be x square minus 2x, and the last one will be x power 4 minus 2x square. So 5 definitions for f of fx. This holds true when x belongs to open 0 to 1. You have to solve the intersection of these two intervals. This holds true when x belongs to 1 closed root 2 open. Okay. Third definition, x belongs to minus infinity to 0. Then fourth definition, x square minus 2x. This interval is only possible when x equals 0. The intersection of these two sets is only one point, x equals 0. Over here we have the interval as x belongs to root 2 to infinity. So students, looking at the definition, this is the first part of the definition starting from minus infinity. After 0, this is the second part because this is just a point. Then this is the third part. Then this is the fourth part, and then this is the fifth part. Moving from left to right. So points of non-differentiability. Starting from the left, minus infinity to 0, the definition is x power 4 plus 2x square. At x equals 0, the answer is 0. After x equals 0, the answer is x. So definitely x equal to 0 is a point of non-differentiability because the slope of the curve changes instantaneously from a biquadratic expression to a linear expression. Then talking about x equal to 1, again the slope will change because the definition goes from x to 2 minus x square. So x equals to 1 is also a point of non-differentiability. Further we talk about x equals root 2. Yes, again quadratic expression and a biquadratic expression. The slope will change. You can check these 3 points separately. These are the 3 points of non-differentiability. Okay, so total 3 points. No doubt this was a lengthy question, but yes, it is a very conceptual question. Option number 3 holds true. Okay, let us move on to question number 64. Question 64 says that Lagrange's mean value theorem is applicable to the function fx is equal to signum of x plus 1 plus lambda times x minus 1 by 2 whole raised to the power 2 by 3, where x belongs to 0 closed 3 by 4 open and 1 when x belongs to 3 by 4 closed to 1 open. We know that students, signum of a positive quantity is always equal to 1. So simply fx is equal to, in this particular interval 0 to 3 by 4, x plus 1 will be 1 to 7 by 4. 1 plus lambda into x minus 1 by 2 whole raised to the power 2 by 3 when x belongs to 0 to 3 by 4, and 1 when x belongs to 3 by 4 to 1. Students, the function must be continuous and differentiable in the interval 0 to 1. Obviously it is continuous if LHL is equal to RHL. 1 plus lambda times this has to be equal to 1. Lambda has to be 0. There is no other possibility. We have option number 2 as the right choice. A very simple problem. Okay. Let us move on to 65. Question number 65 says that the differential coefficient of sine inverse 2x upon 1 plus x square with respect to cos inverse 1 minus 4x square upon 1 plus 4x square. We'll have to use different substitution in both the cases, and we have to find d of this term sine inverse divided by d of cos inverse. So in the first term, I'm going to put x is equal to tan alpha, and this will be sine inverse of 2 tan alpha upon 1 plus tan square alpha, that is sine 2 alpha. So this is 2 alpha simply, and that is 2 tan inverse x. Let it be fx, okay? dfx by dgx we'll have to find out. This is gx. I'll put 2x is equal to tan beta. So this will be cos inverse 1 minus tan square beta upon 1 plus tan square beta cos 2 beta, and that will be equal to 2 beta. So 2 beta is 2 tan inverse 2x, and that let it be equal to gx. We have to find out f dash x by g dash x. F dash x is 2 upon 1 plus x square. G dash x is 2 upon 1 plus 4x square into 2. So 4 upon 1 plus 4x square. Differential coefficient of this with respect to this, f dash x upon g dash x. So the answer will be 1 plus 4x square upon 2 into 1 plus x square. So that will be 4 plus 4x square minus 3 upon 2 into 1 plus x square. So when you will divide the first two terms, 4 into 1 plus x square divided by 2 into 1 plus x square, you will get the fourth option as the correct choice. Okay, 2 minus 3 by 2, 1 plus x square will be the answer. Option number 4 is the right choice. Okay, let us move on to 66.